How's it going?
Wow.
Kidding.
Okay.
You're welcome.
Okay, so let's talk about some of these problems. Okay? So some of you were talking about question number 17, or problem 17. So let's talk about that in terms of how that's going to play out. So what I hate about having two threads. Okay, so when the displacement is 1/2 A, what fraction of the mechanical is kinetic energy and what fraction is potential energy? Okay, so here's the story. So there's a couple of ways you can do this problem. But here's the bigger idea, is that the total amount of energy that the system is going to possess is fundamentally the sum of two things. It's the sum of some amount of potential energy and some amount of kinetic energy. Okay? That's what you got. Those are two values added together. So one way you can look at that, and it's a PhET simulation of masses. So let's say that I'm going to hook up a 195 gram mass to this spring. Okay? And I'm going to make it where I'm not losing any energy to thermal. So notice as this thing oscillates, you have kinetic energy, which they show in green, potential energy due to gravity, and then they call it PE elastic, which is the energy stored in the spring. Okay? So notice that that total bar, which is your total energy, that height is always staying the same. Right? You only have a certain amount of energy that's within this system. So you're down here at the bottom, kinetic energy goes to 0. As it goes up, your kinetic energy drops back to 0. Because that's when you're changing direction. That's when the velocity is going to equal 0. So here's your potential energy due to gravity. Obviously, that's going to be biggest at the top, and that's going to be smallest at the bottom. Potential energy due to the spring is like the inverse of the potential due to up. So all you're doing is continuously transforming that energy from one type to another. Now, the cool thing about this is also showing your velocity and your acceleration. So your velocity vector is in green, your acceleration vector is in yellow. So when that starts to fall, notice that right there in the middle, that acceleration vector changes sign. Why does that acceleration vector change sign? Because right in the middle, what's the value of your acceleration? 0, because that's the point that your net force equals 0. So as this thing is going, speeding up, slowing down, whoop, stops, speeds back up. But then when it crosses the middle, then that velocity slows down and changes direction. So your kinetic energy is continuously changing because your velocity is continuously changing. So the other way that you can view this in terms of a graph is that you could set up a time graph. And let's say that we're going to start at the top of the oscillation. Let's make it a little, and then we're going to go down, and then we're going to end up at the bottom of the oscillation. So if I were to do a graph of different types of energy, OE and kinetic, right? So when it's at the top of the oscillation, what's the only type of energy that it's going to have? Gravity. So this is going to be all some type of potential energy. Kinetic, potential, spring, something like that. I'm just going to call a generic value of U, right? My kinetic energy is going to be 0. So as it falls, as time goes by, what's going to happen to the value of U? It's going to become less, and my kinetic energy is going to increase. So at any point, I could add those values together and get some amount of total energy. Okay, everybody cool with that? At some point, this is the whole idea of energy being conserved. Now, if you look at the extremes, if you were in the middle of the oscillation, if you're in the middle of the oscillation, what's the only type of energy that we're kinetic, okay, which is going to be your maximum velocity. So you could set 1/2 m v max squared, okay, because that would be your maximum amount of kinetic energy. So whether you're oscillating like this in terms of just u, or if you have a horizontal one where it's oscillating back and forth, doesn't make any difference. To get your value of u, okay, what's that going to be in terms of amplitude?
1/2 Ka squared.
Beautiful. 1/2 Ka squared. So 1/2 Ka squared plus 1/2 mv max squared is going to equal that total amount of energy. Okay? Cool with this idea. You have to understand that first premise. Okay? So here's the basic idea on 17. So on 17, you're told that when the displacement of the mass is 1/2 of A. Okay? So you're going to have 1/2 K, but then what's A going to be?
1/2 squared.
Well, 1/2 A squared, right? Go with this. So when you do that, you get 1/2 K times 1/4 A squared. Now, we're going to do a little bit of hocus pocus here. Could I write that as 1/4 1/2 Ka squared? Is that legal, what I just did?
Sure.
Absolutely it is. Okay, all I did is take the 1/4. But here's the bigger truth, because here's the problem. Everybody wants to get, y'all want to get wrapped up in numbers. Going, oh man, this sucks. What number? Well, use my calculator. Okay? No. So if this is 1/4, basically 1/4 u, okay? So if that's 1/4 u, what does your kinetic energy have to be? 3/4. Right? So if you don't get wrapped up in the numbers, you can actually see a much deeper truth. Okay? Does that make sense? Now, on B, at what displacement as a fraction of A is the energy half kinetic and half potential? Okay? Cool. So what you want to do is say this. So I want 1/2 of my potential energy, right? Okay? To equal 1/2 of my potential energy, which would be 1/2 of 1/2 Ka squared. Cool with that?
Is the other one kinetic?
Huh? Yeah, it doesn't. It's if you want to do it with kinetic, it would just be V max. It would be the same idea. It would be 1/4.
Is the U kinetic in this situation?
No, U is potential. U is always potential. K is going to be kinetic. K is always going to be kinetic. U is just going to be some type of potential energy. It's because on 17, it asks for, if I remember right, what displacement is the fraction of A's energy half kinetic and half potential? So it doesn't make any difference where I put the 1/2. I can put it with the K. I can put it with the U. But it asks, in this case, it asks for amplitude. So here's the bigger idea. What's the generic way to find any type of potential energy stored in a spring? This is the most generic way. 1/2 Ka squared. 1/2 Kx squared. Right? Okay? Now, over here, I've got 1/2 of 1/2, which is 1/4 Ka squared. Right? So I want this energy, right? I'm trying to figure out where that x is. Okay? So I want half that energy to be 1/2 Kx squared. I don't know what it is. But I know that I want 1/2 of it to be kinetic energy. Excuse me, 1/2. I want 1/2 of it to be potential energy, which is going to be 1/2 Ka squared. So all I did was I said, I want 1/2 of that to be U. If I wanted half of it to be kinetic, I would put 1/2 mv squared. Okay? But here's the problem in terms of kinetic energy. It's a wonderful thing. But if you go back to this simulation, in terms of what I can measure, it would be very difficult to measure velocity. Why would it be difficult to measure velocity? It's always changing. It isn't like I can take the displacement and divide it by time. Okay? So it's very difficult for me to measure velocity. But it's pretty easy to measure distances. So if I can measure my distances, like for example, if I know what my amplitude is, then I can figure out what my total energy is. From there, I can figure out my Vmax. Okay? So it's very difficult to physically measure your Vmax because your velocity is always changing. But it's much easier to measure the displacement. That I can measure. Okay? That's easy. Velocity, not so much. So this is why a lot of times we go off amplitude. Okay, so back to our story. So on this story, so I've got 1/2 and I have 1/4. And I've got k's on both sides. So conveniently, what's going to happen to my k value? I don't even have to have the k value. So I've got 1/2 x squared equals 1/4 a squared. So basically what I want to do is express this in terms of a. So what are you going to do? Okay, there's any number of things that you can do from here. Okay, but you want to get basically, you want to isolate a. Now, if this flips you out, Berkey up, I hate dealing with variables. I hate this. What would be like a simple amplitude to use? 1. Okay, you could literally make up numbers. Okay, you could put in it would be god awful big to have an amplitude of 1 meter, but the math would work out. Okay, you could literally make up a k value. Let the k value be 10, let the amplitude be 1. So you would have this side of the equation, and then you would take half of that. That equals 1/2 kx squared. And then you could literally solve that for x. If you don't like working with variables, you can literally make up numbers. The same mathematical relationship is going to happen. Okay? It's just you want to deal with numbers, you want to deal with variables. Okay? But it's the exact same process. So, and there's a couple of ways you can express your answer to 17. If you go through all of this, it's 1 over the square root of 2. So you could put 0.707, which is 1 over the square root of 2, or times a, or you could put 1 over the square root of 2 times a, or you could write that as a over the square root of 2. Okay, I don't care how you do it, just pick one. Okay, cool with that. Okay, on 20, that answer should be between 5 and 8, closer to 5. Right? Let me see. On the multiple choice on 24, on the questions, 24 should have a lot of B's. Not all of them, but you should have a lot of B's. Yeah, on 24 on the question.
Are we solving for A?
Number 11.
Right.
Problem or
Like with the equation, we're solving for A.
Question.
For
Problem number 11.
solving for A. Okay.
yeah.
I'm going to say, I'm going to go L.
What do you do? What are problems?
I
What
go
are
L.
problems?
Okay.
Not the word. What is a problem?
Don't say anything.
A problem is something that. What do you do with it?
Bert.
Yeah.
What?
Can we go over
I solved
6?
both of these.
B, C, D,
Yeah,
D.
let me get those numbers out.
You answered one and you solved one. You answered one and you solved one.
Okay.
I saw both of them and I answered both. I provided an answer, therefore I
We overthink it.
Little guy.
What is this concept? What is an actual problem? So
On
like
E, I got
questions.
The question is the concept. On E, I got B.
Concept.
Which one's the concept?
The question.
The question.
Okay. So number 11 is a classic example where this is an obscure equation, and I would give this to you on the test. Okay. So to get your acceleration, it's just 2 pi f squared times your amplitude. And again, look at the units, okay? What units do you have to end up in? Meters per second squared. Now, obviously, if there's no amplitude to the swaying of the ship, what's your A max going to be? 0. Okay. By the way, if you ever get a chance to go on like on an ocean cruise or something like that, don't. I did it once. Swore to God I never do it again. Huh? No, never did. It was just I was just bored out of my mind.
It was not that
No,
boring.
no, there's not.
How did you do that?
No.
20.
Yeah, but me, I was bored out of my flipping mind. Walked around, saw the ship, and thought, great, I'm on this thing for 7 more days.
I'm trying to figure out how to work right
And that's a whole other thing. That also made the whole trip. That's a whole other story. What?
Is that a problem or a
now. That doesn't-
This is a problem.
What is the problem?
I'd like to give it one. I'd like to give it the first 24 questions, the other than half the problem. The labels in the
Okay, so these kids have all been through the process.
Yes.
So
We can make
this,
it quick.
if you want to take this for college credit, give Megan a moment of your time. You want access to this or?
No, we don't have to.
Okay.
Who is interested in the Physics 2 credit? It's only if you enrolled and took Physics 1 and passed it last semester for college
Which
credit.
they all.
Okay.
Wait for it, does that mean honors physics too?
Yeah, it's the same.
Will you guys keep your hands up so I can give you these?
Huh? No, don't.
No, but I'll take this.
Yeah, again, if you're doing engineering, do not take this for dual credit. It will not count, okay? But if you're in the vet school, even if you just need elective credits, which everybody does, it's great to have. What's your elective credit? Physics. Most people take like history. I was talking with some people that were in the case they were taking like history of country music as their So
We used to have some language classes when I
I
was
don't know
there.
why you have to do it. Like, why can't? Shouldn't I be able to do it with time or period?
Okay.
If you guys are signing up, do
period
you
was-
want to pull out your Chromebooks and we can add the class
yeah,
really
if
quick?
you're doing this for dual credit, get out your Chromebooks. Make this happen.
Initially, where would you rank it? Oh, yeah, I forgot.
I said problem, boom, question, boom.
One of the dogs, so I remember that questions
Okay, period is.
Most likely, that's a generalization, but yeah.
It would, to find the period, it'd be 12/2.
Okay, if you guys want to pull up your Jumpstart account, so this is mine,
Yeah,
Jumpstart.wctech.com.
Oh, that's what they say, questions on the problem. Oh, I was wondering. I was like, oh, why did they say that?
Is it WC Tech or what's it?
Question or problem?
You would favorite the
Right there.
Friday, and now I don't really call you at all.
I don't know. Where you put it?
Yeah, that's my problem, and I find answers I don't have to work.
Okay. Okay. So at any point,
Mine saved, so I don't
potential
even know.
plus kinetic. Okay? So this particular one, you're told
Like, I think.
that the amplitude that is half would be awesome.
That's what
Oh, I think it's when the
The first part, they tell you specifically what it is.
Alright, buddy.
Okay?
Oh,
So that's why you know that's 1/2 it.
Okay, if you guys
So-
are on Jumpstart, you're gonna go to enroll in classes, and then it's gonna list everything inside the piece.
People need to listen to what she's saying.
It's gonna list all of the classes within Maze. The physics 2, it's gonna be at the bottom of the first page. If you don't see it, just let me know. What I enroll you? After you find the class and you click the little box to get the blue check mark and then hit green for selection, we're gonna go to the parental consent form on the website. So if you are not 18, you just have to remember that somebody else is responsible for the payment for the class. So they have to sign off acknowledging that. If they don't sign this, I cannot enroll you. If they don't see it in their email, sometimes it goes to the spam account. If they don't get that, then you can email me and I can send you the link. Okay, and then last thing, if you guys have not paid for your Physics 1 credit last semester, I cannot enroll you into Physics 2 until that has been paid for. So last day to get the parental consent form signed and make sure that you don't have a balance on your account is going to be February 13th. So we have about a month. I'm going to send you guys text and emails, so make sure that you're looking at that as well. And then once you are enrolled, I'll send you an invoice that's going to go out on the 20th. It's going to be an email to your the email that you used to log into Jumpstart, and that's going to have your instructions for how to go pay online. So if you didn't pay online last semester but you want to this semester, that's how you can do that. And then payment is due on March 2nd, and it doesn't have to be paid in full. You can pay for a little bit at a time for this Physics 2 class, but if you haven't paid for Physics 1, you'll have to pay for it in full to be able to enroll in this class. Do you guys have any questions for me? No. If you do have any questions, that HS admissions email, that's on the bifold I just gave you guys. It's also at the bottom of your Jumpstart account. You can always email me, use your name and your high school so that we know who we're talking about. So that when it goes to our entire high school team, they forward that email over to me.
For that FERPA consent, I did it this morning. Do I need to do it again?
No, just once. Yep.
Physics Hold'em?
Yes.
Okay. So, you want, so, you should know the type of. There we go. One half x squared. All I did is I took one half turns one half.
Spring of 2026, right? Yes.
So I've got one half x squared minus one half fourth.
Oh, that's such a good signature.
Then if I do
I have to do that. I have 4.
okay, roll the 2, which makes it the same.
So the only one's that wrong is 6. Or not wrong, but like,
Okay.
That's different.
Yeah, I might think yes. I thought you said.
Just thumbs up if it's good.
I was like, wait, what?
Alright, yeah, because the units.
Okay, I'll leave a couple of these for you as well.
Okay, alright, thank you.
Thanks.
I got one. She said.
Okay, yeah, and if you have any questions, email Megan,
I missed
don't ask me.
6.
Because she knows everything and I don't. So back to our story about cruisers, okay? So this is giving you this value of A max. To a certain extent, it's just plug numbers in, okay? You know what the frequency is. If you look at the units, because frequency is in radians per second, but that's going to get squared. You multiply that by the amplitude in meters, you get meters per second squared, those are A max, okay? Now, obviously, as your amplitude gets bigger, what's going to happen to your A max? It's going to get bigger. The farther the ship sways, okay, the bigger your A max is going to be. All right? As frequency doubles, as in other words, it oscillates a lot more for unit of time, what would happen to your A max? If you double the frequency, what would that do to your A max?
Probably quadruple it.
Yeah, because you go up by a factor of 4. Okay? So it's just plug and chug into that. That's all. And if you wanted to, because, and this is something Nathan had brought up, because omega equals 2 pi f, you could write that as omega squared alpha. It means the same thing. Okay? This depends on which one you look up. Anyway, there's that. Any other questions?
6.
Oh,
Question 6.
question 6 or problem 6?
Question.
Let me find it.
Can you give a ballpark answer?
Huh?
A ballpark answer?
Yeah.
On 6?
Yeah.
And then
Somewhere
explain
between
it.
25 and 30. So, on number 6, because you're talking about like this thing oscillating,
Yeah.
so you got a maximum amplitude of 20 centimeters. So, what you're going to look at is 1/2 K A squared. Because at those extremes, you have either all amplitude or you have in the middle what's all kinetic. And again, it's tough to measure kinetic, so we measure amplitude. So then, all that's happening on number 6 is you're told, hey, what will be the amplitude if the maximum kinetic energy is doubled? So, if we double the kinetic energy, that means we also have to double this amount of energy. So I want this to be 2E. So 1/2 K. So the question being is that what do I put in here for this value since it's squared to double that energy? Well, I obviously can't double it because if I double my amplitude, what would happen to my energy? It'd go up by a factor of 4. So doubling it would be too big.
Yeah.
There you go. But if I put in the square root of 2A squared, square root of 2 squared is 2. That's
I get that, but like, how would you get squared to solve it? You know what I'm saying? I get why you squared it 2, but like, you just said, go ahead and square it 2, and then you get 2. I mean, I get that, but
Root 2, what squared equals 2?
all right, bro, I'm good. I'm good.
Our brains are.
I took college out.
Did you?
3 did.
Are you in top 3 right now?
Did that answer that popcorn?
Yeah.
Okay.
Oh, holy fuck.
All right, anything else? Go once, go twice.
Oh, yeah.
Okay.
So, yes, when you stay for them, please stay for them in a logical order.
Make sure the whole fine.
Stop! You guys suck at basketball.
What do you mean, you guys? It's him. He's the
I'm gonna shoot from the corner. They got just know more vocabulary. Have you seen that Family Guy episode?
Oh, I think I was still.
Huh?
The Family Guy episode? You believe that where they're playing like the basketball game and they get sucked in?
I thought it was like,
Yeah, okay, please, Nathan.
I appreciate it.
I will when we get to the harmonics and strings.
Okay, that's
So, oh, that's yours. I'm so used to seeing mine.
I think I'm gonna say close to know what time. Never mind, I guess it's probably
No, should I add it to my vocab?
Oh, added this you.
Yeah, I should add it to my vocab.
Nihilism?
I've added 3 words today.
Yeah.
what does it mean?
Well, let's see. How do you spell it?
Yep, never stopped.
All right, so here's the drill. So we're gonna finish up chapter 14. This is one of the shortest. So we'll finish this up today. You got about the same length of assignment as you had Friday, that for tomorrow. And then we'll review tomorrow, and then the test is gonna be on Wednesday. Okay? So that's kind of the sequence. There's not a lot, it's just over chapter 14. And like I said, don't memorize the equations. I will always give you any of the weird equations. But this is what you should be able to do. So right now I've got this spring oscillating back and forth, okay? And based upon the fact that we could measure the distance, so if this thing is oscillating, okay, so we measure the distance. We have a stopwatch, so we can measure some things with that. So here's my question. What are some things that you could figure out if you collected data?
Frequency,
Or periods.
Period. Okay, all right. So let's do this. So I'll start it when it's at the top. Okay. And this is in slow motion, by the way. Okay, so I got a period of 1.12 seconds. Okay, so t is 1.12 seconds. So I got that number. So what could I do with period is 1.12 seconds?
You have your frequency.
So that's technically 1.12 seconds per oscillation. Okay, we don't put per oscillation, but that's implied that that's there. So then my frequency would be what?
1 over f. Or t equals 1 over f. 1 over t.
1 over t, right? So I can take 1 over 1.12 seconds and get what?
893.
0.893 seconds per revolution. Now, I know the mass that's oscillating on that thing is 195 grams.
You can find your K.
How could I find my K value?
T equals 2 pi root m over K.
So period equals 2 pi times the square root of
M over K.
m over K. Right? So I know everything but K. So this is something you should be able to do without hesitation. So I need to get K by itself. So what are you going to do?
Divide by 2 pi.
Divide by 2 pi.
And of course the k and the t.
And then I would square both sides, and that gives me m over K.
K equals m over that one.
So then if it were me, because I hate fractions, I'd write that as t squared over 4 pi squared equals m over K. What do you think I would do next?
Cross multiply.
Cross multiply. So I'd get kt squared equals 4 pi squared m. Then what? Divide by t squared. Right? Cool with this. So somebody take 4 pi squared times the mass of 0.195 kilograms. Divide that by, what was period? 1.12 seconds squared. So what do you get?
6.87.
What'd you get?
6.87.
6.87 newtons per meter. Now, what units do you get out of this? No, you don't. You get kilograms per square. What? Newtons are what? Kilograms meters per second squared. The meters cancel out, and you get kilograms per second squared, which means the same thing. Okay? Cool. Now, so I'm going to stop this. Okay?